Hello, Math 8 students. This is Miss DeWitt. Today is Wednesday, April 13th. Today we're going to continue our discussion on the Pythagorean Theorem, and we're going to focus more on the formula. Now, I'm not going to sing the song for you, but the Pythagorean Theorem says that the sum of the squares of the two shorter sides, we call those A and B, are equal to the square of the longest side, which is the hypotenuse, C. So a squared plus b squared equals c squared. So Pythagorean theorem works only on right triangles. So unless that triangle has a right angle right here, this does not work. And the sides labeled C is always the hypotenuse. So the longest side is always C. One way I remember, if I can't quite tell if it's the longest side, like the sides kind of look really close, is I always look for that 90-degree angle. And that little corner right there is a 90-degree angle. You look for that 90-degree angle, and you can tell that that 90-degree angle, I think of it as like an arrow. And that arrow is pointing right at the hypotenuse. So the hypotenuse is the longest side. And is always opposite from the right angle, the 90 degrees. And so we know that the two smaller sides are A and B. Now, A and B are interchangeable. A and B are any of the two sides that make up that 90-degree angle. Oftentimes, the way I remember it is just the shortest side is A and the next shortest side is B. You could write, this could have been B and this could have been A. Those two are interchangeable. The only really important thing is that that longest side is your hypotenuse, C. So let's use that formula and let's go over here in this first example and calculate how long is that longest side. Well, first of all, let's highlight that longest side. That longest side is right there because that 90-degree angle is pointing right at that longest side. And so excuse me, I'm allergic to the Pythagorean theorem, I guess. So, just kidding. So I'm going to say that A is 4 and B is 6. And I don't know what C is. So I'm going to use my Pythagorean theorem to solve for C. So 4 squared plus 6 squared is going to equal C squared. And so 4 squared is 4 times 4, which is 16. And 6 squared is 6 times 6, which is 36. And we're going to add those together. 16 plus 36 is 52. Now, I remember when I did this in class, and we had that list of perfect squares, and 52 was not on that perfect square. 52 is probably somewhere between 7 and 8, because it's between the square root of 49 and 64. But I want to find approximately what that missing side is. So I'm going to go ahead and I'm going to take the square root. Do you remember how I said that the square root is the inverse of squaring a number? And so if I take the square root of both sides, then C is going to be approximately, and if I do 52 squared, let me do that on my calculator because I can't really think of it off the top of my head. I know it's somewhere between 7 and 8. So 52 and the square root is 7.2, about 7.2, which makes sense that that is the longest side, because if you have 4 and 6, then the longest side has to be 7.2. Go ahead and pause this video and try this next one. Looks like you have the legs are 6 and 8. So go ahead and pause this video. I'm going to work it out, and I will see you after you're done. So you should have gotten C equals 10. That one was nice because it was a perfect square. So I knew that my hypotenuse was unknown. I said that 6 was my smallest side, so that was my A, and 8 was my next smallest side, so that was B. I squared both of those, and that was added up to 100, and then the square root of 100 is 10. Okay, so let's try this Pythagorean theorem rule and determine, is this a right triangle? So it looks like we're given these three sides. So I'm going to order these from least to greatest. So I know I have 15, and then I have 17, and then I have 20. So I'm definitely going to say that my hypotenuse has to be 20. And these can be my A and B. Ordering from least to greatest for me helps me see which one is my hypotenuse. So now I'm going to take what I know is the Pythagorean theorem, and I'm going to test to see, does this work with these three numbers? Does 15 squared plus 17 squared equal 20 squared? Now I think from yesterday or Monday, remember that 15 squared is 225. 17 squared, I'm going to have to work that one out. So 17 times 17 is 289. And 20 squared is 400. And so if I add 225 plus 289, I get 578. Wow, that's pretty big. And that's definitely not equal to 400. So no, this is actually not a right triangle. It's a triangle. It might be a triangle, but it's definitely not a right triangle. So you can test, if they give you three side lengths, you can test to see, is that a right triangle or not? Because if it is a right triangle, it will meet the criteria for the Pythagorean theorem. Okay, you guys, pause this video again, and why don't you guys try the U-try? So I found that yes, these two did add up to the square of 15 squared. So this is a right triangle. So being able to take the three sides, order them from least to greatest, I found A was 9, B was 12, and C was 15. And then I squared 9, I squared 12, and I squared 15. I added the two smaller sides together, and in fact, they equaled the third side. All right, Math 8 students, go ahead and make sure you have all these notes taken, check your playlist, and I think you have a worksheet tonight for homework. Have a good day.